Hello, good morning everyone. Now we are going to discuss oxepines and thiepines. In last class we have discussed azepines. Now today we are going to discuss oxepines and thiepines. Now what are oxepines and thiepines? Oxepines are the 7-membered heterocyclic compounds which are containing oxygen atom as the heteroatom, and thiepines are the heterocyclic compounds 7-membered. They are containing sulfur as the heteroatom. Now, when we see these two heterocyclic compounds, they possess 8 pi electron in the ring system. That means they have 4n pi electron system, and they have according to this, they have 4n pi electron system. They can be anti-aromatic compound, but they have non-planar structure. Because of non-planar structure and 4n pi electron system present in them, they are known as non-aromatic in nature. Now if you compare oxepines and thiepines, oxepines are found to be more stable than thiopine, whereas oxepines can be synthesized and they can be isolated, whereas these thiepines cannot be isolated or cannot be synthesized easily. Now let's discuss oxepine. What are oxepines? Oxepines are the heterocyclic compounds containing oxygen as the heteroatom, but this oxepine is in equilibrium with this valence tautomer, that is benzene oxide. At room temperature we cannot get oxepine itself. See, oxepine is in equilibrium with benzene oxide at room temperature. Now how to synthesize these compounds? Synthesize is quite difficult for both oxepine and thiepine, but then also we can synthesize oxepine and thiepine. Now we are synthesizing first of all oxepine from 4-membered carbocycles. What is carbocycle? Carbocycle means it is not a heterocycle, it's a carbocycle, means a ring containing all the carbon atom. It's a carbocycle. Yes or no? So I have taken bicyclohexadiene. First what I will do? I will do epoxidation. So one of the double bond gets undergo epoxidation, and at 150 degrees Celsius, that is at thermal condition, this rearranges and to form oxepine. But whatever product we are getting here is, it is in the very low yield. Okay, from 4-membered by carbocycle, whatever we have got oxepine, it is coming in the very less yield. So what are the other methods? Now I will use 6-membered carbocycle. Now I will use 6-membered carbocycle. It is 1,4-cyclohexadiene. Now what I will do? First of all, I will do epoxidation. I will get epoxide. One of the double bond will undergo epoxidation. Then what I will do is I will do bromination. Then the addition reaction takes place at this position. Now after that, then dehydrohalogenation. That is, Br will go, H will come here, Br will go, H will come here. So that 2 double bonds are formed. What is this? This is benzene oxide. Okay, which is in the tautomer, which undergoes tautomerism, and we get the oxepine. So this is the well-known reactions of the oxepines synthesis. Okay, then we'll discuss the photochemical and thermal reactions. Now we are taking a compound which undergoes photochemical and thermal reactions, and we get the oxepines. Now what happens here is, now this is a diene molecule. Now it undergo photochemical reaction, that is 2+2 cycloaddition reaction. It undergoes in presence of sunlight. It undergo the see, this bond comes here, this bond comes here, and we get this 2+2 cycloaddition reaction takes place, and we get this structure. Later there is a rearrangement which is taking place at the thermal condition, and we get a oxepine. Okay, same reaction I have shown here. This is a substituted furan which undergo 4+2 cycloaddition. Why it is 4+2? This is 4 pi system and this is 2 pi system. So 4+2 cycloaddition takes place. This bond goes here, and we get this type of structure. Okay, this is a substituted furan reacting with alkene. It undergo 4+2 cycloaddition reaction in presence of sunlight. We get this structure. Further, it undergo like this same way. Now it will undergo 2+2 cycloaddition. Here what we are going to do here is 2+2 cycloaddition reaction is taking place, and we get this structure. When you heat, then there is a rearrangement which is taking place, and which results into the formation of oxepine. This is known as oxepine. I hope you have understood all the synthesis. It's quite very easy, just you have to remember. Okay, then what are the reactions of oxypenes? We know oxypenes undergo very less reactions. Now main is oxypene, it is in equilibrium. Oxypene is in equilibrium with benzene oxide and oxypene. Now what is the reaction? First reaction is reaction with electrophile, and one more is reaction with nucleophile. Now you know benzene, this oxypene is always in equilibrium with this benzene oxide. So whenever a very simple electrophilic reaction is, this oxypenes reacts with hydrogen H plus, that is acid, and it forms the salt. Now further it undergo, now this whatever OH plus is forming here, this undergo CO bond cleavage, any one of the CO bond cleavage, then it will undergo aromatization and it will form a phenol. This is one of the very well known reaction. Now what is the reaction of oxypines with nucleophiles? Usually oxypines will not react with any nitrogen nucleophile, but when this oxypenes, okay, when this oxypenes reacts with azide, it will form this structure. Okay, so only it can undergo nucleophilic substitution reaction with azide ion, remember. Okay, it will not undergo any reactions, it will not form any product with nitrogen nucleophiles. Only it is going to react with the azide ion. Okay, I hope you have understood the reactions of oxypines. Now I have said you that oxypines are quite stable than the thiepines. So oxypines only are undergoing so less reactions, the thiepine are still undergoing very less reactions. Thiepine at room temperature is very less stable, hence it is quite stable in this benzene sulfide form. This is called as benzene sulfide form. This is quite stable in this form, but then also when you heat it for little heat also, if you give to the molecule, it will explode. It will exclude this S from the structure and you will get a benzene ring, that is arene ring. Okay, so it is very unstable molecule, but also some synthesis have been reported, that is one is this one. Okay, now 4,5-dihydrothiepine has been synthesized from this reaction. Now the stability of thiepine. Now how to achieve the stability of thiepine, you know. Now if we substitute, see now second and seventh position, you substitute second and seventh position by some of the bulkier group, or whether it is electron donating group or electron withdrawing group, just you substitute it by bulkier group, so that this molecule will become quite stable. So when this molecule will become quite stable, it can undergo the reactions. So here when we react this molecule with this 4 tetracyano compound, what will happen? A cycloaddition reaction. Once again a cycloaddition reaction takes place, we get this molecule, and whatever product we get due to the cycloaddition reaction, it is known as adduct. We are getting this adduct. Okay, now other than this, what reaction they are undergoing? I have told you they are undergoing thermal reactions. Now what happens in thermal reactions? In thermal reaction, they exclude S from the structure and they will convert into arene. That I have already discussed in this reaction, yes or no? Similarly, even whatever it is, thiopene dioxide, whether it is thiopene oxide, all of them will exclude sulfur and finally they will form arene and whatever byproduct is there. If it is dioxide, it is dioxide. If it is monoxide, it will be SO only. So these are the reactions of thiopenes and oxypenes. Also we have discussed the synthesis. We know both of them are quite unstable because of the ring which they have, and thiopene is quite unstable only compared to the oxypene. So these are the reactions and synthesis of thiopenes and oxypenes. Thank you for watching the video.